In this video, we're going to look at electronic structure. So that's how the electrons are arranged in atoms. Now we know that the electrons are found in orbits around the nucleus, but we need to go into a little bit more detail. So let's think about calcium, which is the biggest atom we need to know in detail. And that's got an atomic number of 20. So that means it has got 20 protons, 20 positive protons. And in a neutral atom of calcium, you've got the same number of negative electrons. So that's going to be 20 electrons. Now, how are those 20 electrons going to be orbiting the nucleus? Well, I'll draw the nucleus. I'll write down as Ca there, it's calcium. And they're allowed in shells. The electrons are allowed to orbit at certain distances from the nucleus. I'll draw 4 in for this one. And the rule is that they will always fill in the inner shell first, and when that's full up, then they'll start filling in the next shell, and so on. So calcium, we've got 20 electrons. Now, the inner shell, you're only allowed 2 electrons in there. The electrons I'm drawing as dots here, quite often they're drawn as crosses. They're either drawn as dots or crosses in these sort of diagrams. And the next shell, we're allowed to fit 8 in there. So we start filling that up. So we've got 8 in there. We're still only up to 10 electrons there. So we just have to need to fill up the third shell. The third shell has also got room for 8. Here's 8 electrons in there. And that's full up. So now we have to start filling up the fourth shell. So we've got 18 electrons there altogether. So we've got room for just 2 more electrons. So you've got 2 in the fourth shell. And quite often that's written in shorthand. The electronic structure of calcium would say it'd be 2 in the first shell, then 8 in the second, 8 in the third, and then 2 in the fourth. That would be the way you'd write it. The important thing there, though, is to remember that this first shell, you're allowed 2 electrons in there. The second shell, you're allowed 8. The third shell, you're allowed 8. And we don't really need to know how many electrons you're allowed in the fourth shell, because the last element we need to know is calcium, but you're allowed more electrons in there. That's the fourth shell. Okay, so let's see how the electronic structures, all the different elements you'll see, describes the element's position in the periodic table. So here we've got a blank periodic table. And then we're going to look at some of the electronic structures of the elements here. So here I've got hydrogen. In that version, it's shown as being in group 1. Most people probably wouldn't put hydrogen in group 1. They'd probably put hydrogen separately as a box of periodic group on its own, but we can stay there for the time being. The other alkali metals in group 1, so you'd have lithium, sodium, and potassium. And there's calcium, the last element we need to know, the biggest one we need to know the electronic structure of. And here on the far right, we've got our noble gases, so helium, neon, and argon. So let's choose an element. Let's have carbon, which is actually there. And that's got an atomic number of 6 if you look it up in your periodic table. So let's draw the electronic structure of carbon, and that will be, so there's our nucleus. I think we need 6 electrons. We're going to need 2 shells. So we fit 2 in the first shell, and we can fit 4 in the second shell. So we write down the electronic structure of carbon as 2, 4. And it probably hasn't escaped your notice, carbon is in group 4 of the periodic table. The groups, of course, are the vertical columns. So that's a pattern you'll notice now, that the number of electrons in the last shell, in this case 4, is the same as the group number in the periodic table. Let's have a look at, well, calcium we've already done. Let's have a look at sodium. Now sodium is the nucleus. Sodium is atomic number 11, so we're going to actually need 3 shells for sodium. Okay, so the first shell, you're allowed, you put 2 electrons in there. The second shell, 8, which takes us up to 10. Sodium's atomic number 11, that means 11 electrons it's got. So there you go, it's got 1 in the outer shell. So sodium we write down as Na would be 2, 8, 1. And we can see, yes, it is in group 1 of the periodic table. So that's good. Right, let's do sulfur here. Right, that's atomic number 16. And it's in group 6, so hopefully it should have 6 electrons on the outer shell. We're going to need 3 shells for sulfur. Right, so 2 in the first shell, 8 in the second. That's full up. Now we've got 10 electrons. That means we've got 6 over. There's 16 altogether. So we need 6 there. Okay, so sulfur would be 2, 8, 6. And it is in group 6. And so that's all worked out well. That fits in the pattern. Now, last of all, before we have a look at the whole periodic table, let's look at this group here, the noble gases. These are really important, and I'm sure you're aware that the noble gases do not form any chemical compounds. Okay, and that's really important. So let's look at helium, the first member of the noble gases, atomic number 2. So just 2 electrons to worry about with helium. So all we need is 1 shell. So we've got, that's like that. Let's do neon, which is the next one. That's atomic number 10. So we're going to need 2 shells for neon. 10 electrons, so we have 2 in the first. And we have 8 in the second shell. That's 10 electrons. That's all done for neon. And then let's do our last one. Let's do argon. So argon is, we're going to need 3 shells. So 2 in the first shell, as usual. 8 in the second shell, which takes us up to 10 electrons. Argon, I should have said, is atomic number 18. So that means we've got 8 left over for the third shell. Now, you've probably noticed there that the noble gases, helium is 2 in the outer shell. Neon is 2, 8 in the outer shell. Argon, 2, 8, and then 8 in the outer shell. The noble gases have a full outer shell of electrons. And that seems to give an atom stability, and that's why they don't react. So that means all the other ones do react because they haven't got a full outer shell, so they want to do something about that. So for example, sodium here has got 1 in its outer shell, that 1 electron, and all the reactions sodium does, it tends to want to lose that electron. That's what it's doing. That's why it's pretty reactive. Sulfur, on the other hand, it's got 6 in its outer shell. Well, it could get rid of 6, but that's a bit tricky. So what it tends to do is gain 2 more. So it could gain 1 there and 1 there. So it'd have 8 in its outer shell. So all the reaction of elements seems to be driven by them trying to get the electronic configuration of the nearest noble gas. Okay, so before we finish the video, let's just see the whole of the periodic table that we need to know there. So I've drawn it. So there, right, so it's not distracting us. I think we'll get rid of this stuff here. Okay. So you can see in group 1 here, we shouldn't really have hydrogen in there, so I'll do a box around that. Group 1, all those elements, the alkali metals, they've all got 1 electron in the outer shell. Lithium is 2,1, sodium 2,8,1, potassium 2,8,8,1, and so on. Group 2, yeah, they all end in 2 electrons in their outer shell. Group 3, 3 electrons, and so on till we get to the noble gas and noble gases, and they have got a full outer shell. Now, before we finish, we should also notice that if you look at phosphorus, for example, there's P, that's 2, 8, 5. How many shells are we using up there? We're using up 3 shells. And if you look, phosphorus is actually, I should put the numbers down here, is in period, that's period 1 there. This is period 2, and phosphorus is in period 3. So the number of shells gives us the period. Let's write that down. period number, and the electrons in the outer shell that gives us the group number. And you probably realize with the periodic table, if elements are in the same group, they show similar chemical properties. And the reason for that is because they all want to do the same thing with their electrons. Group 1 there, they all want to lose 1 electron. Group 2, they all do similar things, so they all want to lose 2 electrons. Whereas you get to group 7, they don't want to lose 7. Much easier for them just to gain 1 to be like the next noble gas. They all want to gain 1 electron. And really, that's what chemistry is all about. It's all about explained by the electronic configuration of the elements.